Hi everyone, welcome back. In the previous video we already talked about this TVL1 optical flow, and also we compared this with the other type of optical flows in OpenCV library. And in this video we are gonna get into the details of these member functions, and we are gonna learn how these parameters are working in our examples. And also we are gonna check if we set smaller and higher values of these parameters and how it's affecting the output video accordingly. Okay. We can switch to the code part. In here, this is the example from the previous video. Extra, I just added this get function to see in the output console because I want to see the default values, and we can set the desired values and we can check the output accordingly for each parameter. And we can start with the get lambda function. Maybe we can first of all run the code, and I'm gonna use this billiard example again, and here are the default parameters of these member functions. Okay, for example, for the get lambda function, the default is 0.15. All I need to do is just copy this part and paste here. So I want to change the lambda parameter with the set lambda. I'm gonna write here the new value. But what this lambda function is doing, for that one I already showed in the previous video. There is an article about this TVL1 optical flow, and here there are detailed explanation of those parameters. For example, now we are talking about the lambda function, and it says in here the smaller this parameter is, the smoother solutions we get. So my expectation, for example, now is 0.15. If we set it to a lower value, I'm expecting to see more high accuracy result. Maybe, for example, just 0.001 and see the result again. Okay, for example, for this moment there is a motion in here already, but maybe before showing this, of course, I need to show you as a reference how this is working with the default parameters. This is the default parameters output, and come to that moment. Okay, there is a motion vector in here I get, and here I see this ball is already moving, and it gives me an output vector which is correct. Also, now we are getting the output with an interval. In here you are gonna see with egg. We are checking each egg pixel. So some pixel in here, I'm sure there are some other motion vectors is giving me correctly. But anyway, in here we get a correct vector, but if we check the new output with high accuracy, we are not getting anything. If we continue a little bit, I still get nothing, because we really increase the accuracy. It means it's gonna detect really if sure it's a motion. Of course, this ball movement is a motion, but it's not detecting because we really increase the accuracy. But in somehow, if we increase the opposite direction, maybe you are gonna understand more clearly. Now the default value was 0.15. Now we increase really high percentage, for example 2, which is 2 times, maybe 3 times higher than the default one, and see the result in here. My expectation is gonna give me somehow not really good results. Yeah, you can see here this may be correct, but this is wrong. There is one more wrong motion vector here. This is wrong motion vector. This is not related with this motion, so it's not giving me correct result even for this moment. Okay, so we already understood this is somehow setting the accuracy, setting the smoothness, and increasing it, decreasing the accuracy, decreasing it, increase the accuracy. So also, by the way, before, maybe I need to tell you, all of these parameters somehow affecting the accuracy. This is the first thing you need to keep in mind. And the other thing, if you increase the accuracy, most of the times the speed is gonna decrease, and in the opposite case it's gonna change. Yeah, for example, lower accuracy is gonna increase the speed, and higher accuracy is gonna decrease the speed. So there is a trade-off always. Anyway, we already checked this lambda function. The next is theta function. For that one, all I need to do is just change this with the theta, and the theta default value is 0.3. and here we can check the documentation again what theta is doing. This was smoothness parameter, and this is tightness parameter, and does it say anything? It should have a small value in order to maintain both parts in correspondence. So it's suggested to give smaller value, so it's 0.3. Maybe we can try with if smaller is better, maybe we can try 0.001 again, which is really smaller than the default, and we can check the result. Yeah, maybe this is related to the theta. Before we check the lambda function is similar, maybe it's really increased the accuracy and it doesn't show me anything. Maybe we can check one more scene. Still it doesn't show anything, but let's see the opposite direction again. Maybe maybe we can give 100 and see the result again. It's really slow. Why it's really slow? My expectation is now the accuracy is gonna decrease. That's my expectation. Now I'm trying to forward the video, but it's really slower. It's going really slower. The why is slow? Because my expectation accuracy is gonna be low. If we can see the result in here, let's see if it comes. Okay, now it come to this scene, but we see there are many noise. It's not working fine. There is motion in here, but there is nothing motion vector in here, but non-relevant places there are many. So this is of course as expected, because it's suggesting smaller values. We really increased to the 100, which is higher value. The accuracy is decreased, but also you can check differently. In this case, the speed also decreased, so it's going slower. So but because most of the times if the accuracy is low, speed is high, but in here accuracy low but speed also low, so very bad case. So my expectation, because there are many motion vector wrong, even wrong, is finding for every pixel, it's calculating, and that's why I think it's slower also. So we need to be careful about setting this theta. And the next parameter, we can switch to the epsilon parameter, and we can change the theta with the epsilon again. Okay, the default value for the epsilon 0.01. We can check the documentation again for epsilon. It says this is stopping parameter, and small value is gonna give you accurate solution again. So theta and lambda, with similar theta and lambda, they are also lower values, high accuracy. This is also lower values, is gonna give higher accuracy. We can try again 0.001, which is smaller than the default value, and we can check the scenes in our video. I can say this is also slower and expected, because we are trying to increase the speed accuracy. If it comes to our popular scene, okay, but different than the theta and lambda is giving a motion vector for this ball, and I think this is better than the default one, because the default one is giving a 90 degree. I think it's not really correct, because it's going in this direction and the motion is in this direction. I think this is working, this epsilon value, trying to increase the accuracy now, and I think this is working for our case. So I think this is a better motion vector than the default one. So yeah, now we increase the accuracy and it's also giving us good results. And we can try with different values. For example, the default was 0.01. Maybe we can try with the 1. Now our expectation is also now we decrease the accuracy. It's really high speed now, and somehow it's giving vector, which is not really wrong. We can see. Okay, I think it's giving one more here. So now we try to decrease the accuracy, but in our case still is somehow giving, in some parts, giving correct results for this stick also. So maybe, but the conceptually, just keep in mind lower values for epsilon also is gonna give high accuracy. Anyway, we can switch to the tau, and we shouldn't delete that. Okay, just write set tau, and tau default value is 0.25, and we can read the documentation again for the tau. It says it's suggested to give the values be lower than 0.125, and it can also take the value 0.25. So the default is already 0.25. Let's try to give 1. I think it's not gonna work if I'm not wrong before. Okay, it's really slower. Really slower. I think we are not gonna get any moment because it's not moving even. So we need to keep obeying to the documentation. It says just give the value, for example 0.1, which is lower than 0.125. This kind of a special parameter, I think, but it's still little changing the direction of the motions, but nothing else I see for this scene. At least you can see one more scene, it's giving still better results. So default is 0.25. If we give 0.3, for example, what happens? I think for other kind of values except these values, just before also I tried this parameter, try to give the parameters lower than this, or just give the parameter this, which is the default one, this one. So this tau is somehow special parameter. You can experimentally find the correct parameter in your projects, in your cases, so just keep in mind. And we can skip this tau also. The next is scales number, and the default is 5 in here. And this scales number, I think maybe we can read the documentation in here again. Okay, it says if the flow field is very small, which is the target motion object, target object which is moving is really small, it says in the image approximately 1 pixel, it can be set to 1. So we can set this parameter 1 if our object is really small, closer to the 1 pixel. Otherwise it should be set to this according to this formula, which is the default one is 5. I can say for this parameter, for smaller objects set it to the closer to the 1. For the higher, I mean for bigger objects in your image, I'm talking about the pixel wise, of course, set it to this bigger than the 5, I can say. And we can try, for example, default was 5. We can try with the 10 and how it's affecting our video. Let's see. Yeah, I can say it's not affecting much. This is default behavior also. Just I can see this is little increased. This is in here 1, 2, 3 pixel distance. Here also same. Yeah, it's not really changing much because yeah. But just keep in mind this scales number about the size of the object in pixel wise. Yeah, if really smaller objects, you can set it to the 1. We can skip to this warping parameter. I think it's also in here. Represent the number of times there are some formulas in here. It says stability of the method. It also affects runtime. Yeah, of course there is a trade-off, of course. We can check the default value of this get warpings is also 5. We can set it to the, because it doesn't say smaller values what it does, we can set it to the 1. The default was 5, which is we are setting to the 1 now. About speed is really faster, but yeah, now we understand the lower parameters for this one. In our case at least, decreasing the accuracy because this is not expected. Let's see one more scene. Not really good, I can say. Okay, but not really bad also. But speed is really high, I can feel. And we can set it to the 10, which is higher than the default value. Default was 5. And now it's really slower, I can feel. The expected behavior is gonna be expected behavior is also accuracy is high. So yeah, at least at the beginning. Maybe we can again our popular, I just rerun. Okay, you see we don't see this extra, which is wrong motion vector in the other direction. We don't see it because in the we try with the value 1, it was giving extra motion vector, which is wrong in here. Now it's not giving. So higher values for this warping number getting high accuracy, lower values low accuracy, we can say. But of course speed is in the opposite logic. This initial flow is 0. This Boolean parameter, we can check also this Boolean parameter. if you set it to the true, it's gonna crash. I think now it's true. We can try and see the crash. Okay, it crashes because it expects in the calculated value this flow is actually at the beginning is empty. You need to fill this flow accordingly for the calculated function, and then you can use initial flow to the 1. So this is really rare cases you are gonna need this, because for example we are getting this video, but if you already have some information, some other video media source, then you can add this video which is following the previous video. Just all you need to do is saving flow from the previous video and giving it to here, then you can continue to calculate the new motion vectors accordingly. Yeah, I'm not gonna try this. And median filtering, the default is 5. I also tried this before, and for example this is in the documentation it writes nothing, but I already know this is affecting the medium filter in the behind about the scene. Somehow it's just applying medium blur, which is we know. And here we can try more than 5, let's say 7, but it's gonna crash. But because they designed this in this type, it doesn't let you the values which is bigger than 5. So they already set to the 5, which is the highest value and the default one. But you can try with 1 or 3, which is lower than 5. You can try with those values. Now the speed is gonna increase, but for the smoothest backgrounds, maybe you can play with this parameter because it's gonna increase the speed. Extra, you don't need to set it to 5 because it's gonna decrease the speed. So if it is working fine in your case, the value 1, why you need to use the default 5? Because it's gonna it's not efficient. It's gonna decrease the speed of the loop. Yeah. Anyway, for this video, we already learned all these member functions, and we already checked. Again, there are the people who are interested with this article. They can check this in the internet and they can find. And yeah, we already talked about all the parameters. And thanks for watching. See you in the next videos.